Hello students, today we will solve one more problem, that is the X bar problem. So here they have given the components need to be turned to a diameter of 25 mm on a CNC turning machine. So a sample of 15 has been drawn and table below shows the dimensions which are measured using a vernier caliper. So sample number, that is small n, is 15 and they have given the dimensions, that is the diameter, which is measured with the help of vernier caliper. So here they are asking us to draw a X bar chart and to give the recommendation whether the lot can be accepted or not. So first of all, number of components is 15, that is nothing but the sample size small n, and they have given the dimensions 1 by 1. Now solution. So for X bar chart, what do? We have to find the control limit, that is the X bar, and upper control limit is X bar plus 3 sigma. So you have to find X bar value and sigma value. Lower control limit is X bar minus 3 sigma. So where sigma value is summation of xi minus X bar whole square divided by n. Okay. And X bar is equals to sigma of xi divided by n. So we know n value. Now they are asking the sigma or summation of xi. So this dimension which they have given is nothing but xi. So summation of these values, that is adding up all these values, we will get the sigma xi value, that is 375.25. So when you add up all these values, you will get xi is equals to, that is summation of xi is equals to 375.25. So that is 375.25 divided by n is 15. So the answer we will get here is 25.017. So X bar value is X bar is equals to 25.017. So we have got the X bar value. Now we have to find this sigma value or the standard deviation. To find standard deviation, we should know the summation of xi minus X bar whole square. So X bar value is obtained, xi value is given. So for every sample we have to find this value, that is xi minus X bar whole square. So from this table which I have drawn here, we will note down all the xi values which have been already given, that is 25.02, 24.89, 24.92, and 25.05. So now we know the X bar value. So X bar value is, we have already calculated it as 25.017. So xi minus X bar, that is 25.02 minus 25 for the first, for first component, xi minus X bar is equal to 017. 25.02 minus 25.017, which will give us minus 0.003. So we will get some value as 0.0009. So whenever we get a value which has 3 zeros after the point, we will let us consider it as 0. So minus 0.003. Here the square value, this is the square value. When you square this, you will get 0009. So this value, let us consider it as 0. So in the same way, for second component, xi minus x bar is equals to 24.89 minus 25.017. So again we will get 0.127. So when you square this value, you will get some 0.127. When you square this value, you will get some 0.002. So in the same way, for all the 15 components, we will calculate x minus x bar and then we will square the value. So we will get different values, that is 0.097. When you square it, you will get 0.009. Then you will again get minus 0.003 here. So we will consider it as 0. Then minus 0.063. When you square it, you will get 0.004. Then you have minus 0.053. You will get 0.003. Minus 0.093. 0.009. 0.087, that is 0.008. Now here minus 0.013. So again you will get a 000 value after the point. So we will write it as 0 here. Then minus 0.103, that is 0.01. Then again minus 0.033, 0.001. Then we have 0.037, that is again 0.001, minus 0.013. So again a 3 zero values after the point. So we will write it as 0, 0.067, 0.004, then minus 0.033. That is nothing but when you square this value, you will get 0.001. So after you have obtained all the values for each and every component of this xi minus x bar whole square, then you have to find the summation of it. So summation of xi minus x bar whole square. So when you add all these values, you will get 0.052. So now sigma is equal to root of summation of xi minus x bar whole square divided by n. So this is the whole summation. So sigma is equals to root of 0.052 divided by 15, which will give us 0.015. So the sigma value is 0.015. Now we will calculate the control limits. So for the control chart, we need the control limits. For the control chart, control limit is equals to x bar. We had already written it. So control limit, that is x bar, is 25.017. Next, the upper control limit is equals to x bar plus 3 sigma. So that is equals to 25.017 plus 3 into 0.015. So the upper control limit is for x bar is 25.062. So this is the upper control limit which we are calculating using this formula. Then the lower control limit for x bar is equal to x bar minus 3 into sigma. So that is 25.017 minus 3 into 0.015. So this will give us an answer 24.972. So now we will plot the graph. So as you can see here, I have already plotted a graph. So the number of components, that is 15, I have taken on the x-axis. So this is the x-axis and this is the y-axis, and here I have taken the dimension. Okay, so 24.88, then 24.90, okay, 24.92. I have taken the dimension or the diameter which is already given. So based on the component, the values or their dimensions are marked here. So after marking them, we will join these straight lines, and also we will mark the upper control limit value. So UCL, you can see I have drawn here. So the value which we got for UCL is 25 point. So UCL is 25.062. Okay, so here the UCL lies, and here there is LCL, that is the lower control limit, which is marked here. So LCL is 24.972. So I have marked it here. So you can see there are points, the 4 values fall outside the upper control limit, and also there are 4 values which are falling outside the lower control limit. So you can see 1, 2, 3 and 4 values are below the lower control limit, and 1, 2, 3 and 4 values are above the upper control limit. So this indicates that because the points are outside the upper control limit, this process is not under statistical control. According to the control chart, it shows that there are 4 points. So according to the control chart, it shows that there are 4 points lying above the upper control limit, suggesting that the process is not under statistical control. So even we can find that there are values below the lower control limit, and so further investigation is suggested to determine the causes for the process to go out of statistical control. So this is all about the X chart or X bar chart problem. I hope you have understood the problem. Thank you.